Hey guys, sorry, my last video cut me off. So if you take a look at number 3 on the handout, so this question says, triangle A prime, B prime, C prime is a scale drawing of triangle ABC drawn by using the ratio method. Use your ruler to determine the location of the center O used for the scale drawing. So in this example, all they want us to do is find the center of dilation. So all you have to do for something like this is using a straight edge, connect each image point to its corresponding pre-image, and draw that line nice and long. So connect A to A prime, B to B prime, and C to C prime. All right, and what you should notice is that all 3 of those lines intersect at the same point. So that point is point O, your center of dilation. All right, so that's all you have to do if you're asked to find the center of dilation. All right, just connect the pre-image with its corresponding image. And then where those lines intersect, that's your center of dilation. Okay. So question number 4, this is a question I'm going to leave for you guys to try on your own. But basically, you're going to dilate the segment below using a scale factor of 5/2. So remember, 5/2 is equal to 2.5. Okay, so you're going to dilate by 1, 2, 3, and then use a bisector to get 2.5. Okay, so questions 4 and 5. I'm going to leave for you guys to try on your own. Okay, so if you take a look at the next part is scale drawings without respect to a point. Okay, so when they ask you to perform a scale drawing without respect to a point, you're going to perform the dilation with respect to one of the vertices. Okay, so if you look at option 1, what we're going to do is we're going to dilate this triangle, and I'm going to dilate it by a scale factor of 2, and I'm going to have it centered at vertex A. Okay, so I'm going to use vertex A as my center of dilation. Now really, they could have you use any vertex. A was just the one that I picked. Okay, so what I'm going to do is I'm going to extend segment AB nice and long, and I'm going to extend segment AC nice and long. Okay, so point A doesn't move because that's my center of dilation. All right, so I'm going to take my compass, and I'm first going to dilate point B. Okay, so just like we did before, metal point goes on the center of dilation, so on vertex A, and I'm going to extend to point B. Okay, so this right here is a scale factor of 1, and I'm going to do that again because I want a scale factor of 2. Okay, so this point right here is B prime. Okay, now I'm going to dilate point C. So I'm going to put the metal point at A. I'm going to adjust my compass up to point C. Okay, so from A to C, that's a scale factor of 1. Then I'm going to move up to that point. So that's a scale factor of 2. So this right here is C prime. So now I'm going to take my straight edge and I connect B prime to C prime. So now I have a triangle that's twice the size of the original. Okay, now this point, if you want, you can call it A prime or you can just leave it A. All right, A and A prime in this situation are the same point. All right, So that's dilating with respect to one of the vertices. Okay? Where it says option 2 on your paper, you can ignore that. All right, so what are the properties of a well-scaled drawing? Okay. Corresponding sides are in proportion. And corresponding angles are congruent, right? Because the figures are similar. What is the term for the constant of proportionality by which all lengths are scaled in a well-scaled drawing? That is what is called the scale factor, and it's represented by lowercase r. Okay? All right, so one more example. We want to use construction tools to create a scale drawing of the following triangle with a scale factor of 1/2. Okay, so again, they didn't tell you what point to use as your center of dilation. So you can use whatever point you want. All right, I'm going to use point D. All right, so I'm going to scale back point F and point E. All right, so again, we're talking about a scale factor of 1/2. So we're going to have to use a bisector here. Okay, so I'm going to put the metal point at D. All right, I'm going to open up my compass more than halfway, swing that arc above and below, turn it around, do the same thing on the other side. Okay, so if we line up those very close arcs, we know that this point right here is F prime. Okay, so now I'm going to do the same thing to DE. All right, so metal point at D, extend more than halfway. All right, draw that arc above and below. Turn it around. Do the same thing on the other side. Okay, so this point right here is E prime. So now I'm going to take my straight edge, connect E prime to F prime, and here I have a triangle that's now half the size of the original. All right, and again, if you want, you can call this D prime, you don't have to. Okay, so the rest of the questions in the packet, I'm going to let you guys try on your own. All right, I don't think there's too many left. And when I come back to school, if you guys have any questions, of course, we could take a look at this together. But I think you guys should be able to manage this. All right. I will see you guys on Friday. Have a good day.